Okay, now we're going to take our first set of measurements now. Can we just remind ourselves what we're doing what for? Okay, now have a look at this sheet, or throw them on the floor if you wish, but if you'd like to look at the sheet with, or a sheet with the measurements that you're about to take. Now this is the other element of what we're doing today, isn't it? This is the collection of statistical data to test a model. What model are you testing today? The Bradshaw model. Now the Bradshaw model is basically a set of statements that say certain things change as you go downstream. Now let's remind ourselves so we're all aware of why we're doing this. Yeah, because we're potentially going to do 7 different sites. I doubt if we'll do 7, but towards that number of sites. Okay, well, however many you've got, that it's one set of one sheet for one site.
So do you count this as site number 1 or 2?
Well, that's up to you to have a system. If site 1 was the source, but we didn't take any measurements, this is going to be the first site where we're going to take some measurements. So I'd say make it site 2 if you like. If site 1 was the source, but we didn't take measurements. Yeah, so this is the second. And have we got a grid reference? Have we worked out where we are?
No, we haven't.
It's going to be fairly close to where we were last time. So have a look, see if you can sort out. If we're going to take a measurement here, isn't there a space for a grid reference on your recording sheet? Okay, so we need to find the grid reference then. So any suggestions where we are? 42, 2 or 1 even? 94. Yeah, I think I'd go with 94.3. I don't think 6. That was back to boiling well, wasn't it? We have walked down a little bit. Okay, so if we say, what did we say? 42, 1, 9, 4, 3, something about that. Okay, if that's going to be our first location for these measurements, let's just remind ourselves what measurements we're taking and why we're taking them. What does the Bradshaw model say? What is going to change as you go downstream?
Deepness gradient.
Deepness of what?
Channel.
Right, we're not talking about the whole valley here, although that does do that. We're talking about how deep the water is in the channel. Yeah? What else are we going to check?
Channel width.
Channel width. We'll come to that one in a minute, because I think if we're talking about the depth, we're also talking about the width. And if we've got those measurements, we could work out, if we wanted to, something called the wetted perimeter, couldn't we? Remember something called the wetted perimeter? If you've got a cross section of your stream, and that might be relevant later on. Okay, so we got width and depth. What else have we got? Discharge, yeah. Now what do we mean by discharge of a stream?
The amount of water.
The amount of water in it. And how would you measure that? How do you measure it in the textbooks? If you're sort of talking about this river had so much water in it, they measure it in what units? Cumex, very good, which is cubic meters per second. Now you think about what a cubic meter looks like. That's a meter cubed. That's a big lot of water. Is this anything like a cubic meter?
No.
So this is going to be 0.000 something. So whenever you come to work out your calculations later on, if you're getting 100 cumex coming down this stream, you're obviously way off in your calculations. Why? How are you going to calculate discharge? How on earth will we work out how much water is going down this stream if we're going to take some measurements?
Area.
Right.
So much water, like with the cork, you put the cork in at one end of the main hole, and then you measure how long it takes to get to the side. You should do an average.
Okay. So that's how quickly it gets from one place to another. Is that discharge? So that's velocity. But that is something we are going to measure. So we're going to measure how quickly the water's flowing. And yeah, but I'm asking you how we're going to, you said discharge is one of the first things we take. It is something to do with the pulse. But you're talking about how we're going to measure speed. And yeah, we are going to measure speed in a minute. Cubic meters per second. Sorry?
Cubic meters divided by second.
Yeah. Cubic meters, we've got to know the cross section of the stream, haven't we? And in order to work out the cross section of the stream, we've got to do the width and the depth. Because we've got to draw a little cross section of the stream and then say how fast it's flowing. So in order to work out the discharge, you need the width, the depth and the speed to get your Qmex. So that very first one on the Bradshaw model, discharge, is actually the most difficult one to work out because you need all the other measurements and then you've got to do some complicated sums. And that's why I was talking about your 0.00 Qmex, because a Qmex is a huge amount of water compared to this stream. Okay, so now we're going to do some measurements. We have got to divide ourselves up, division of labour, to collect all the data we require for there. How are we going to do the speed? Over what distance?
10 meters.
That is one way we could do it. If we put a cork in that stream, shall I show you what happens? Just totally by coincidence, I think somebody's been here before. What's that? Come here. Just saw that. What's that? A cork. Is it travelling anywhere? We've got a real problem. This high up, the stream is little more than a trickle. We might be able to get it to roll for a bit, roll stroke float, but rolling along the stream is not really measuring the speed of the stream, is it? Rolling along the bed. So we've got a problem with a cork, which we might find, not only is it going to be shallow, it's going to get caught up in the weeds, isn't it? There is another method. Have you not seen that box before? Where is it now? Flow meter. Where did somebody get out? How are we going to measure the gradients? That's something we haven't even talked about yet. The gradient of this. With a thing called a thing. Clinometer. Who's got the blue circular object called a clinometer? Do you know how that works? Has anybody got a tape so we can put those bars or the poles 10 metres away from each other? So let's get the two ranging poles 10 metres away from each other. Right, is that the stretch that we're going to do? Are you happy that that's the stretch? That's 10. Okay, let's get the tape out of the way then. Try and keep it out. Yeah, -5 I'm guessing. Because you're going down. All the black flecks through that. So, pardon? Minus. Right, okay, we've got a bit of a leeway of 8 here. From 5 to -3. -3, okay. If she did it from here and went that way, it'd be +3. It's just that the gradient here is 3 degrees, okay? Are we going to record that? Oh, that's a good idea. So, site 1, the one that you've got that grid reference for on your sheet of paper, we have got an angle, a gradient of 3 degrees. So that's adjusted to the right position. I'm now going to put this in the stream and hopefully it's deep enough for that. It is moving. Advantages and disadvantages of the methods that you used. There is a very obvious disadvantage of a cork in a small stream at site 1. It's getting caught by the weeds, it's getting caught in the very shallow Very shallow stream.
Why did you reach it?
This is a channel, yes? Just come here a second, Jack. There happens to be today that much water in it, yeah?
Yeah.
If it was still within its channel, but there was lots more water in, where would you say would be the top of the channel?
Well, just below that overhang.
So would you say that all of that up to about there, would you say that's the channel?
That's about it, isn't it?
So this is the channel, and that's how much water happens to be in the channel today. So when it says bank full, if this is the bank, you've got to measure that distance as well. So this idea of a bank full, how big would the stream be if it was full? Today there's only that much water in. Okay, so what does it say you've got to fill in? What do we need?
That's the width of stream, the width of the bank thing.
And do we need width of the channel as it is today?
Just like width of stream and then bank thing.
Right, width of stream. Okay, so we do need to know the width of the stream. We also need to know the width at bank full. We got a tape.